We're moving into inequalities with this video, and in this video we're going to cover just the basics of an inequality, and we're going to start with the word itself. Notice I have the prefix in highlighted here. The prefix in before word indicates not. So an inequality is not equal. Okay, think about that. That prefix inequality means it's not equal. The symbols that we use with inequalities are greater than, and this is strictly greater than, less than. Remember, the symbol always points at the smaller number. So greater than. 5 is greater than 3. 2 is less than 10. So that's how we use greater than or less than. Now, we can introduce the conjunction or. Hopefully you're familiar with what a conjunction is. You should have learned that as a part of speech in English. The conjunction or in this phrase, greater than or equal to, means that we can say this. Here's the symbol, greater than or equal to. So we could write a statement and say that 5 is greater than or equal to 3. That's a true statement. Less than or equal to. So less than or equal to. Notice that this is like a compound symbol where it's one or the other. So let's see, we could say 10 is less than or equal to 10. Is that true? Think about it. Yes, because of that conjunction or, 10 is less than or equal to itself. So this is a true statement, one that might look a little bit better. 10 is less than or equal to 12. So that one's a little more obvious. But think about the conjunction or. One or the other must be true. Everyone is either a boy or a girl. Everyone is either right-handed or left-handed or ambidextrous, means they could use either hand. So or means that one phrase of the compound, one part of the compound phrase is true. And then of course, with inequalities, sometimes we just have something that we're just simply not equal to. And that's an equal sign with a slash through it. So these are the symbols that we use with inequalities. Greater than, less than, and this is strictly greater than, strictly less than. Greater than or equal to. Less than or equal to. And then simply not equal to. 1, 2, 3, 4, 5. These are the 5 symbols that we use when we're discussing inequalities. Let's keep moving. So, we also have an inequality essential question. So when we're talking about inequalities, we're not necessarily looking for a single answer or a single solution. So our essential question for inequalities is going to be, what solutions? Notice that this is plural. What solutions will make it a true statement? We're still trying to make a true statement here, but now we may not just have one answer. We may have lots of answers, infinitely many answers. That's why we're going to ask what solutions, a set of solutions. So the plural of solution. So let's consider these two inequalities quickly when thinking about this essential question. So if we have x is greater than 5, x is strictly greater than 5. So one thing you can do here is anytime you see the variable expression, you can just replace it with the phrase, our answers. Our answers are greater than 5. So if X represents our answers and we want to graphically show the solution set, illustrate that on the number line, then I'm going to put 5 right in the middle, 5, 6, 7, 8. Remember, we read from the left to the right, so be sure that your number line gets bigger from the left to the right. So 2, 3, 4, 5, 6, 7, 8. Now, our answers are greater than 5. That means that 6 is one of our answers, 6.5 is one of our answers, 7 is one of our answers, 7.9. What about 5.1? Yes. But what about 5? Is 5 greater than 5? No. 5 is not one of our answers. So to show that, we're going to put an open circle over the 5. That open circle is non-inclusive. So please note that. We show strictly greater than with an open circle over the 5. But our answers are every single number, every single real number bigger than 5. Our answers are everything greater than 5. That's how we show it on the number line. Let's look at X is less than or equal to negative 3. So, or equal to, if we think about that, remembering that conjunction is saying our answers could be smaller than negative 3 or equal to negative 3. So when we show this on the number line, and let's get our number line set up, we'll put negative 3 right there. So negative 3, negative 2, negative 1, negative 4, negative 5, negative 6. I'm just putting negative 3 basically in the middle. You're going to label your number line in order to meet your needs. So is negative 2 in our solution set? Is it one of our answers? Is negative 2 smaller than negative 3? No. Is negative 3 less than or equal to negative 3? Yes, it falls in the or equal to. So it's going to get a solid circle this time. Is negative 4 smaller than or equal to negative 3? Yes. Negative 5, yes. What about negative 5.5? Is negative 5.5 smaller than negative 3? Yes. So what we're going to be doing is this time shading to the left, because all of these numbers are our answers. Remember, every time we see X or our variable, we're thinking the phrase, our answers. Our answers are less than or equal to 3. So, because of the or equal to right there, that is going to indicate a closed or solid circle. However you want to say, you could even say filled, closed, solid, filled. So when it's strictly greater than or less than, it's going to be an open circle. But if it has the or equal to, it will be a closed circle, showing that we are including the number. So this next little slide, we're going to compare and contrast equations with inequalities. And we're basically working from right to left. So here's the equation, and we're going to compare that with the inequality and see how the solutions differ. So actually, I'll even cover up this problem on the bottom just so it's not a distraction. So if we have 2x minus 5 equals negative 17, I want you to follow the same steps. I want you to keep your equal signs lined up, just like you're going to be keeping your inequality signs lined up. We're going to use the properties of equality in order to solve for x like we did in chapter 1. So we're going to start with plus 5, 2x equals negative 17 plus 5 is negative 12. Divide by 2, x equals negative 6. X is negative 6. There is only one answer here that is going to make this equation a true statement, and it's negative 6, and that's it. So if we were to put this on the number line, it would only have one solid circle, and that solid circle would be on -6. No shading. If we're dealing with an equation, there is no shading whatsoever. But we will have shading when we are graphing the solutions for inequalities. Same process, add 5, 2x is greater than -12, divide by 2, divide by 2, but not equal to, x is greater than or equal to -6. So when we put this on the number line, we don't just have one answer. We have infinitely many answers that will make this inequality true. So let's get it on the number line and we'll test one of those. So -7, -6, -5, -4, -3. So this is a or equal to, so closed circle on -6, and then our answers are greater than -6. So we will shade to the right. Now the easiest number for us to pick that's bigger than -6 and plug in, let's let x be 0. Think about it. 0 is greater than or equal to -6. That's a true statement. So when I plug 0 in right there, we should get a true statement. And I'll do that right over here on the right. So 2 times 0 minus 5, is that greater than or equal to -17? 2 times 0 is 0. 0 minus 5 is -5. Is -5 greater than or equal to -17? If you're a little bit confused, think about it. Would you rather owe someone $5 or would you rather owe someone $17? -5 is a greater number than -17. This is farther to the left. So this is a bigger number, so it's true, so it works. Every single number that's in that shaded region to the right of -6 will continue to make this a true statement. Let's keep going and let's move a little faster. So down at the bottom, we're going to solve the equation and note that we only get one answer. +4, +4. It's the same procedure. Divide by 2, divide by 2, x is 6. We get 6. Same procedure here, except it's strictly less than. +4, +4. 2x is less than 12, divide by 2, divide by 2, x is less than 6. Remember, if it's strictly less than, it will be an open circle because strictly less than 6 does not include 6. 4, 5, 6, 7, 8. Remember, make your number line meet your needs. It doesn't have to include 0 every time. So we're going to say that 6 is the limit, but then we're going to allow everything to the left of 6 be in our solution set. So when we have an equation, we get one answer. But when we have an inequality, we get infinitely many answers. Why? Because our answers are every single real number less than 6. Let's keep moving. Same situation. Equation on the left and inequality on the right. Now we've got variables on both sides. So one of the things that I'm going to remind you of in the next video, again, when we go over the steps very succinctly, we always want our variable on the left. So I am going to add 2y, and get 5y minus 21 equals 4. Now I am going to add 21. Notice I'm keeping my equal signs lined up. 5y equals 25. Divide by 5, divide by 5. Y is 5. One answer. Only one answer when we solve an equation. But when we have an inequality, infinitely many. But the same procedure. Get the y over on the left. So y's cancel. There's my 5y again. Line up your inequality sign and follow the same procedure. Our answers are less than or equal to 5. So when we put this on the number line, just put that 5 right in the middle, and all you got to do is put 2 numbers around it. It doesn't have to be big and fancy. So since it has the or equal to, it will be a solid circle, and we will shade to the left. So that means that 4 would make our inequality true, 0 would make our inequality true. We could check it with 0 very easily, because 0 would basically take out that term and that term. And is negative 21 a smaller number than 4? Of course it is, because any negative number is always going to be smaller than a positive number. Let's move quickly. Number 4, we need to use the distributive property first when solving this equation, and we get 3p minus 3 equals 3p plus 2. Now, I hope that this is ringing a bell in your mind, because what's happening here in number 4 is a special situation. We have 3p on both sides. So what if we subtracted 3p from both sides? We end up with negative 3 equals 2. Is negative 3 equal to 2? No. This is not an equation. This is an inequation where we need to use the not equal to. So if we get a situation that is false all the time, we know that there is no solution. Well, how does this play out when we have an inequality? We're still going to use the distributive property. But now, remember, we're always asking what is going to make this a true statement. Now, if we use our properties of equality here, or in this case, properties of inequality, if we subtract 3p from both sides, and this time I'm not just going to cancel and get rid of it. I want you to think about it. This is 0p. 3 minus 3 is 0. 0 times p. So 0p minus 3 is less than 2, and then we add 3, 0p is less than 5. If 0 times p is less than 5, think about it. What is 0 times any number? 0 times any number is always going to be 0. And we can't divide by 0. That's impossible. We talked about that in chapter 1. So, what are our possible values that will make this a true statement? Well, let's plug some in and give it a try. What if I let p be 10? 0 times 10 is 0, and 0 is less than 5. So p equals 10 works. What if I plug in a negative 10? 0 times negative 10 is 0, and 0 is less than 5. Negative 10 works. What if I let p be 0? 0 times 0 is 0, and 0 is less than 5. Yep, that works. So I hope what you're thinking is that I could continue to plug in numbers all day, and everything I plug in will always work. Therefore, my answer is the whole number line. All real numbers. One last quick problem here in our last minute. Let's solve the equation. Using our same strategies that we learned in chapter 1, lining up my equal signs. I get a equals 6. But look on the inequality side. Going to use the same steps, but let's watch because the glitch occurs. What is the glitch? Let's check it out. Remember, we want our variable expression, our variable a, we want it on the left because that's how our brains work. Our brains read from left to right. We want our variable on the left. I'm doing the same exact steps from the equation. But this time, I've got an inequality And this time I am dividing by a negative. This is the glitch. So I'm going to circle the inequality sign right here. And here's the deal. Whenever we multiply or divide by a negative sign, the inequality sign is going to flip. So what was greater than, or excuse me, yes, what was greater than is now less than. And here's 6. Let's put 5 over here, 7 over here. This is strictly less than. It is an open circle. We shade to the left. Let's plug in 0 because 4, 3, 2, 1, 0. 0 is in the solution set. If we let a equal 0, then it takes out that term and that term. And is positive 20 greater than negative 10? Yes. So our solution set is confirmed.